Hi, I'm Srinity and with me are Heather, Azim, Galen and Tsepeng. Together we created a game called Whac-A-Mole, a fast-paced arcade game with math twist. In this game, players are shown a math equation and must whack the mole that displays the correct answer. Each correct hit earns points and wrong answers cost a heart. You start with 3 hearts and the game ends after 3 mistakes, making it fun, fast and educational. The game runs on a custom engine made up of 6 main components. Firstly, we have Entity, which handles all game objects like moles and the hammer. Next, we have Scene, which manages the flow between menus and gameplay. Collision, which detects hits using Box 2D physics. Input and Audio manages clicks and plays background music. Animation gives visual feedback with sprite effects. And Equation dynamically generates math equation. This all comes together to create the architecture of our game engine. Now I'll pass the time over to Tsepeng.
Hi, I'm Zipeng. I'll be presenting on both the entity component and the equation component. The entity component is responsible for managing all game objects and interactions. At the core of this system, it's the entity manager, which acts as a centralized controller for handling entities. Its primary responsibilities include entity lifecycle management, such as adding, removing, and disposing of entities, as well as game logic coordination, where it interacts with other systems like the collision manager to ensure smooth gameplay. Entities in our game fall into 2 categories: contextual entities and concrete entities. Contextual entities, which include the interactive object and 2 classes, are not specific to our game simulation, but can be used in various scenarios, while concrete entities, such as mole, game tile, and hammer, are directly tied to our game's mechanics and define key gameplay elements. At the foundation of these entities is the entity class, which serves as the base for both contextual and concrete entities, ensuring consistency and reusability across different objects in the game. Next, we have the equation component. The equation component is integral to the game's educational mechanics, allowing players to engage with math problems seamlessly within gameplay. This component is structured around the equation generator factory, equation generator interface, and concrete generator classes. Our equation component follows the factory design pattern, specifically through the equation generator factory class. This factory serves as a centralized system that randomly creates the different equation generators while keeping the instantiation logic hidden from the client. At the core of this system, it's the equation generator interface, which defines a contract with essential methods shared across all equation generators. Building upon this, we have concrete generators, which specialize in generating equations based on different mathematical operations, including addition, subtraction, multiplication, and division. Next, I'll pass on the presentation to Heather.
Thank you, Zipeng. Now I'll be talking about the different scene components. First, we have the main menu scene, which manages user interaction when the game launches. From here, the player can either start the game or quit the application entirely. Next, the game scene serves as the core of the experience, integrating educational elements through interactive gameplay mechanics. It manages the real-time interaction between the player, UI components, and game logic to create an engaging learning environment. The scene continuously updates key UI elements, such as the score, timer, and lives display, ensuring that the player receives immediate feedback on their progress. In addition to rendering visuals and animations, the game scene processes user input through event listeners. Whether the player is solving equations, selecting answers, or interacting with on-screen elements, the scene determines the appropriate response, adjusting the game state accordingly. This allows for a dynamic experience where difficulty can scale, new challenges can be introduced, and rewards can be granted based on performance. Furthermore, the game scene interacts with various supporting classes and methods to maintain smooth gameplay. It communicates with the equation generator to create new problems, updates the game logic to validate responses, and notifies the scene manager when transitions, such as moving to the end scene, are required. Once the game ends, this end scene comes into play. It allows users to either restart the gameplay or quit, while also simultaneously communicating with scene manager to display the final results. Next, the scene manager acts as a central hub for handling different scene transitions and rendering to ensure a smooth gameplay and user experience. Lastly, we have the base scene, which handles the state of all scenes, whether inactive or active, and controls their behavior. It also initializes the UI components, backgrounds, game objects, and sets the stage for the game. All these components are created for an interactive game flow. Now, I'll pass the time to Galen.
Hi, I'm Galen. Our collision system, which is built on 5 components, each with a distinct role, crafted to deliver a scalable and maintainable architecture. The collision manager takes charge of collision detection, employing AABB queries to pinpoint overlaps and efficiently notify listeners through callbacks while steering clear of game logic responsibilities. Next, the physics manager operates the Box 2D world, seamlessly handling simulation steps, body management, and position updates, keeping physics isolated for clarity. The collidable interface standardizes how objects engage with the system, offering methods for body access and collision responses, ensuring flexibility across entities. Meanwhile, the collision listener interface empowers external components to respond to events like hits or misses, cleanly separating detection from action. Finally, collision config optimizes performance with Box 2D's category and mask bits, precisely controlling interaction. This design reflects the single responsibility principle with each component focused on one task, enhancing modularity. It embraces the open-close principle, allowing new entities to join without altering existing codes, and uphold discourse substitution, ensuring any callable fits effortlessly. Together, these principles create a robust foundation, ready to scale up with future enhancements. Now I'll pass the time to Azim.
Thank you, Galen. Let's talk about our next components, input and audio. Keep in mind there are 2 different components, however, for the sake of brevity, we're talking about them together. As Trinity mentioned, there is the input component which handles inputs and also the audio component that manages audio, music and sound effects. From part 1, these are no different except for 2 new improvements. For the input side, instead of inputs immediately being registered and firing off in their own separate functions, they are now kept into a list and executed in a new function called handle inputs, which fires on every render call in Game Master. This segregation allows for inputs to be registered not on just libgdx's library, but from other sources as well, thus centralizing input handling. The other improvement is towards the audio management side. With new changes to the internal structure to accommodate for the music queue, music can be pushed into queue and played back to back. For example, in the end scene, we have a brief track for that feeling of accomplishment before playing the main jungle theme again. This improvement also solved instances of overlapping music tracks, as now, any track that wants to be played would need to go through the music queue. Next, we have the animation component. This comprises of the Anim Manager class and Sprite Animation class. Since this component didn't exist in part 1, I'll go more in depth here. Starting with Sprite Animation, it is responsible for processing a sprite sheet into usable frames of texture animation and drawing them. These are used by entities such as the hammer and mole for their click and pop-up animations respectively. Where they are created is where the Anim Manager comes in. This class creates, stores, and manages these sprite animations before putting all of them into their respective templates. The templates are actually what is assigned to the entities. So for example, 2 different sprite animations, one of a mole popping up, and the other of them being whacked, is placed into the mole template, which is then assigned to the mole entity. Doing it this way allows for more robust assigning of animations, as we can simply group sprite animations together, and the only thing entities have to worry about is what template they are using. So in general, the animation component simplifies the rendering of animation frames, and for an animation to be played, they can be called for within an entity object. So that comes to the end of our components. Now about our AI usage. We use AI mainly to rewrite portions of the report for better readability, and use it for improving our code based on the solid principles. We also use it to guide us on how to make our game more interesting in terms of educationally, and also finally to debug our errors in the source code. Finally, it's demo time.
Okay, so here's our main menu scene, which shows the play button and the quit button. Quit button will quit the game, play button will go to the game scene. And the cursor is being followed by the hammer there. So we hit play. Okay, let me pause first so I can explain the elements here. So we have the time, we have the score, we have the hearts, we have the streak, and we have the pause, which I just clicked. So we can immediately go to the end scene or we can resume. The pause scene also pauses any spawning of the moles, which you can see. So it keeps things easier for me to explain. Okay, so let's resume. The equation that we have to solve here is 9 minus 8, which is 1. So when we click on the correct mole, it will increase our score and also +1 to our streak. And if we click on the wrong mole, it will deplete a heart, won't add anything to our score, and it will reset our streak to 0. 5 plus 2, this is 7. If the mole that pops out is the correct answer as well, but we don't hit it in time, then our life will also deplete. If I just randomly click anywhere also, it will deplete the heart. Okay. Find the 0 count. 3 times 6, 24. I mean 18, 18, 18. Okay. Minus 1. This is an 8. Negative 1. Yeah, I'm just trying to get a high enough score so that it appears in our leaderboard in the end scene later. Maybe just after 1 more. Okay, now for me to kill myself. Okay, here is our end scene. It keeps track of the accumulated score, our total score, and our time that we survived. So wow, look at that, we managed to reach rank 2 in the leaderboard, which is quite an accomplishment. And from here we can also play again, or we can quit again. And just to show it off, like that, and also we can quit. Okay, so that's our demo, and thank you.